In this final video, we're going to complete our analysis here by computing the F value, which will indicate whether the relationship is statistically significant or not. And so what I'm going to do here is I'm going to type in another heading. And the first thing we need to do is to calculate our F value that we've often referred to as F calculated or F obtained. Now, to calculate the F obtained from our data, this is going to be equal to the equation that we have, our reference equation, which is our variance due to the model divided by the variance due to the error or residual term. Keep in mind the terms error and residual are used interchangeably. So I need to locate the mean square for the model, and that's what we have right here in this cell. And I'm going to divide that by the mean square related to the error term, which is right beside it. Now we have a really large F value, so this indicates to us that this is very likely going to exceed the critical value. But let's go ahead and look up the critical value, or ask Excel to look up the critical value. So I'm going to give this a heading, F critical. And instead of looking it up manually in a table, the table is already built into Microsoft Excel, but we have to go and ask Excel to go and look up the specific value. And the way we do that is we hit the equal sign and we use the command F, upper or lower case doesn't matter, so it's f.inv.rt. This is for specifically to calculate the critical value for F. I'm going to shift 9, and I want it at the 0.05 level unless stated otherwise. We'll always go with 0.05, and we type in the degrees of freedom for our model, and the degrees of freedom for our model is a 1, and we comma the degrees of freedom related to our residual term, and in this case it's the n minus 2, or sample size minus 2. That's a 9. We shift 0 and we hit enter. So we see we have a fairly large critical value, and the reason we have a fairly large critical value is because relatively our sample size is actually quite small at 11 participants for a study like this. But nevertheless, what we see here is that because our obtained F value from the data exceeds that of the critical value, then we can conclude that the relationship between these two variables are considered to be statistically significant. Now let's go ahead and calculate the actual p-value or the probability of committing a type 1 error related to our data. And so I'm just going to put this as a label as our p-value right below it. And I'm going to ask Excel to calculate or look this up for us, and that's going to be F dist, and this is going to be based on the F distribution. And I'm going to shift 9, and I need to type in not the critical F value but the calculated F value from our data. So I'll just click this cell right here. I'll comma for the degrees of freedom for our model, which of course once again is a 1, comma the degrees of freedom related to the residual term, which was 9, shift 0, and I hit enter. And we see that our p-value is 2.64 times 10 raised to the negative 5. So this is a really small p-value, indicating that our F obtained is far to the right on the F distribution, way into that tail region. Okay, a couple more measures to calculate here to round this complete analysis up is we need to calculate the R squared value. And I'm going to show you two ways in which we do this. The first way is the most straightforward, is that we just take our R value, our correlation coefficient, and we raise it to the power of 2. So I'm going to hit equal. I'm going to click this cell, so it'll bring the value in that cell, shift 6, 2, and hit enter. So this is our coefficient of determination at 0.867 506. Now we're going to calculate the r squared value using a different equation. And that equation we see over here on the right. We're going to take a look at the sum of squares, the sum of the squared deviations. We're going to take a look at the deviations generated by the model versus the total deviation, which not only includes the model but also the errors related to the prediction. So the question here is, how much of the model explains the total observed outcome from the prediction, because the prediction will include a degree of error. And we'll go ahead and do this calculation here. So I'll hit the equal sign, and I'm looking not for the mean square but for the sum of squares of our model. We had calculated that earlier, so it's this cell right here. I'm going to / and I need to look for the sum of squares for the total, which we had calculated earlier, and I hit enter, and we see we have the identical r squared that we had calculated simply from squaring the correlation coefficient. Now, if we use the equation in the future to predict an outcome, we do have to consider the degree of error related to that outcome. So this is similar to a standard deviation of a descriptive statistic, so that if we make a prediction like we did here in column G, what is the error related, or the variation related to that prediction? And that's going to be given by what's called the SEE, or the standard error of the estimate. And let's go ahead and calculate that. Now, to calculate this, the standard error of the estimate, we need to understand what the error is related to the prediction, and that's given by the residual. Recall that the residual over here on the right is the difference between the actual value and the predicted value. If this was a 0, then we would have a perfect prediction. But of course, with real data, we never have that. So we want to take into consideration the magnitude of the variation with our prediction and how much of that we can expect. So we've already calculated the sum of squares of the residual term. We've divided it by its associated degrees of freedom, which is the n-2, and this is basically the variance of the error term. And we know that variance units are squared units, but to bring it back into the original units, we just simply need to take the square root of this value. So I'm going to ask Excel to do that, and I'm going to hit the equal sign, and I'm going to use the Excel command for square root, which is SQRT, Shift 9, and I'm just going to click this value right here. I'm going to Shift 0, and I hit enter. So what we have here, and I'm just going to bold this, that if we make a prediction using our regression equation of -3.025 plus 0.613 times some value of marijuana usage, our outcome will have to be taken into consideration of the expected variability, and that expected variability will be a ± 3.85 units. So this ends our final video on regression analysis using Microsoft Excel.